Good afternoon, everyone. My name is Jerich Sison. My student number is 63303400013. And today I'm going to talk about my final project about control system. So this is my project, the load of a DC motor by varying the applied input voltage in Matlab. So DC motor are often actuators in control system. So it used by wheels, drums, and cables, and electric equivalent circuit, as you can see in the pictures. So the physical parameters for this example is moment of inertia of the rotor, motor viscous friction constant, electromotive force constant, motor torque constant, electric resistance, electric inductance. So the J is 0.02, B is 0.2, KE 0.02, KT 0.02, R 2 ohm, L 0.4 H. So the system equation is a DC motor proportional armature, and it's assumed that the magnetic field is constant and it's currented by a I constant factor kT as shown in the equation below. So T equals kTi, and the back EMF is E is proportional to angular velocity. So E is equal to Ke, etc. And SI unit motor torque are equal to Kt equals Ke, and it will be used K to represent the motor torque and the back EMF constant. So as you can see in the picture, this is the Newton's second law and Kirchhoff's voltage law. So block diagram closed loop system labeled all the signals. So as you can see, the loop is from the central ref to positive and negative. And this is the diagram control to going to the closed block. Transfer function applies the Laplace transform modeling equation and express Laplace variable s. So this is the formula of the Laplace and the sample model of DC motor driving an inertial load. So this is the picture. And for the next equation is to the open loop transfer function by eliminating Is between the two above, where rotation speed is considered output and the armature voltage is considered the input. So PS equals this, and K over GS plus B multiplied by LS plus R plus K to the power of squared. So the answer is rad to sec over V. So this is the sample of the code of my Matlab. So I will show you my Matlab. So it consists by the DC motor constant, transfer function, open loop response, closed loop response, state space, checking controllability, draw root, design criteria, desired characteristic, desired pulse, frequency domain analysis, Z domain, time domain, state space design, closed loop, frequency domain analysis, Z domain analysis, and convert to transfer function, PID control, PID transfer function, open loop, TF of the DC motor, closed loop, TF of DC motor, closed loop response of the DC motor, state space design, closed loop response, and the figures. So as you can see, the command window, it shows all the answers. You can see here, here, as the code written and the results. So this is it, and I will show you the figures of the results. So figure 1 shows the open loop response. So you can see 0.05, and the second one is the closed loop response. It's 0, it's 0.50 something, and the second one is the root locus without control. So as you can see, the real axis, it's in the between the -8 and -6, and the imaginary axis is -10 or something, or yeah. And the fourth one is the frequency domain baud plot. So the magnitude is in, it's 0, -20. It's something that like -22 or 23, and the phase degree is in 0 to 180. So for the fifth is the Z domain pole. And so the real part is in the -10 to -8, and the imaginary part is 0. And the second one is -6 between -4. So like something 5. Yeah, and the sixth is the domain, the time domain. It's 0.13 or 0.1299 or something, and the time is 0. So let's go for the figure 8, figure 7. So this is the closed loop. So it goes for the top and then goes down. So it's like 0.0889 or something like that. So for the next is figure 8, the frequency domain. The magnitude and the phase degree. And figure 9 is the Z domain analysis pole zero map. So as you can see, it's nothing, but I will move it here. And so it has an x, and so the real axis is like -4, and the imaginary axis is 0.8, or no, 0.7 something, or I don't know. So for the next one, figure 10, time domain. So figure 11 is the closed loop response of the DC motor. So it goes from 0 to 0.9 and goes again, no, to 1. And figure 12, the plot of the DC motor. So this is my project. This is the load of DC motor applied input voltage. Thank you very much. My name is Jerich Sison, 63303400013.